All right, so in this problem, we have a group of scientists performing several measurements. And what they're doing is they're analyzing the content of acetaminophen in Tylenol tablets. Now, these Tylenol tablets advertise to have 500 milligrams, so they want to analyze and see actually how much is in there. And so these are the measurements that they get from each of these tablets in this batch. And so we're asked to express the size of the uncertainty of these measurements. All right, in other words, describe the precision or quantify it. All right, so there's a couple ways to do it. Probably the most common way to do it with such a small sample size would be to use the standard deviation formula. But my students and most of you haven't taken probability statistics, so we're going to do a simpler method. By the way, if you are interested in this, it's just the sum of all your measurements, the difference to the mean squared over the sample size minus 1 square root, and it's not as complex or intimidating as it may first look. But you can give that a go if you want to challenge yourself or try a different way. But we're going to use a simple approach, simplified method, where we get the mean. Right? So we're going to do that by adding these measurements up, 428 plus 479 plus 442 plus 435. All right, we're going to add up all the measurements. Actually, let me do that right now on my calculator. 428 plus 479 plus 442 plus 435. All right, and then we're going to divide that by the sample size is 4. So just divide it by 4 and got 446. All right, so there's the mean. All right, give myself a little more room. All right, now what we want to do is express a range that includes all of our experimental data. All right, so to do that, you want to identify the high measurement, which is right there, and then the low measurement, which is right there. That's the highest number, and that's the lowest measurement. Okay, and so we're going to take the difference from the mean and see which one includes all these measurements. Right, so 446, that's still just saved in my calculator. I'm just going to subtract 479 from it, and I'm going to get 33. All right, so I can say that may not be my final answer, but I'm going to do 446 plus or minus 33. Right, at least that's the difference that will include the high value. Now I'm going to repeat that with the low value. Okay, so 446 minus 428, and the difference is 18. Okay, so using the low value, I'll get plus or minus 18. Now, that's not the one to use, because if I use plus or minus 18, I'm leaving this value out of the range. So I want to pick a range that's just big enough, yet includes all my experimental values, which is going to be the difference between the mean and, in this case, a high value. It's not always going to be the high value, but it could be the low, but it's whatever that includes all of these. So there's going to be my final answer for this problem. Oh, forgot the units, milligrams. Right, so what you're saying is, to interpret this, if you made more and more of these measures from this batch, okay, so we got to keep that consistent, it's highly likely that you're going to get analysis within this range, 446 milligrams plus or minus 33.